My name is Peter Zonneveld. I'm going to talk a little bit about Mendix and neural networks. So first I'm going to tell you a little bit about what exactly a neural network is, and then I'm going to tell you how we integrated it within Mendix in multiple ways, and give you a short demonstration about the app that we built. So what exactly is a neural network? Well, basically it's a machine learning algorithm that can be used for both regression and classification. The difference between the two is with regression you could get, for example, predict house prices or a statistical number, while with classification you could easily say that is a chair, that is a laptop. It's a different type of process. But like machine learning algorithms, it is fed with a data set, and then the neural network trains itself, with also a little bit of help of a data scientist to keep it on the right track. While the technology isn't exactly new, it's built around the 1950s, it's now more common what we see in our field, basically because we now have large data sets, as well as the computing power to make the calculations. And the funny thing is, a neural network actually also works a little bit like a human brain, so that's also quite interesting to see. And do we already see it in the real world? Yes, we do. We already see it with the self-driving cars that you sometimes see in the news. Even in the healthcare industry, you already see that computer or machine learning algorithms help doctors make diagnosis on patients. But you can also see it with image recognition, also with facial recognition, and also, for example, classifying certain types of damage for insurance companies. So it's already being used quite commonly in the field. But we now have an image, but how can you really classify that? Well, before we get to that, I'm going to tell you a little bit about how a neural network is built. So what we see here is an artificial neural network, and basically what it is that you have an input on the left side. The neural network trains itself to make relationships between those inputs so that it can create a singular output. So in this case, our goal would be to predict a house price based on several inputs. The neural network will train itself to find correlations based on the size and the number of bedrooms, so that it can determine the family size. And the postal code with the wealth combined says something about the school quality nearby. And together, the neural network trains itself to give an indication about what a house price would be based on these input parameters. What is important to tell is that you do need an input correlated with an output, so that the neural network first already knows, okay, result A leads to decision B. So this is a little bit how it works. So what you see here is the number 2, which is written down. The input is sent to the first layer, the relationships are built, and eventually the neural network knows that with these relationships, the handwritten number should be 2. Looks cool. And basically your mind does the same thing by making these relationships like, I know this shape, it should be this, and correlate it to an output that you know. But now we're going into more complex territory. So how do you recognize something within an image? Well, first it's important to know what exactly is the output that you want. For example, with the cat, is this a cat? Yes or no. That's a simple Boolean or yes or no answer that you can do something with. However, you can also make it more complex, that you can have an image and that the neural network can detect certain objects within that said image. So you can see also here that there's a car, a bus, traffic light, etc., etc. Well, then we have to know what exactly an image is in order to process it correctly. An image is basically 3 matrices on top of each other, one for red, green, and blue, with each pixel being a number for 0 to 256. And from that, we want to get a classification, as you see below, that this is a cat. Well, we know that it's a cat, the computer has to know it's a cat. So can we use the neural network that I just explained? No, unfortunately you can't, because what we know and what you already saw, you have to have the input in the first layer, so that would mean that you would have one big vector with all the pixels and numbers after each other, and then have to send it through your network. That would take loads of processing time, and computers simply can't do it, so your model would just blow up. But however, as we all know, this technology exists, so there's a smart workaround around it. And that's basically by using a convolutional neural network. Basically what that does is add a lot of filters over your image. So it will first recognize, are there straight lines? Are there triangles? Are there round things? And eventually it will classify your image so into such a condensed form, which still has all the data that you have, that you are easily able to put it through your neural network. So eventually you'll get to the last part in which you can classify it. Is this a car, a truck, or a van, based on a probability that it has that certain features or shapes of that said object that it has learned. And you can really see it here in this image if you really look closer. So maybe at the end I'll keep this on so that everyone can take a closer look. But what you can see here is that after the first layer is done, you can detect basic shapes. While in the second layer they're more complicated. And eventually here in layer 4 you can already see that the neural network has learned how to recognize dog faces. And here you can see birds, for example. And how much layers that you have within your model determines how accurate your neural network is, and also describes why people use the term deep learning, because that comes from how many layers you have in your neural network. What's interesting to know is that, okay, this is very interesting, how can I do it, how can I train these models? Well, sometimes you really don't, because there are already a few neural networks out there online that you can download, which can easily recognize people, dogs, especially cats, there are a lot of. And you can easily download the weights for that neural network and import it into your own project. However, if you are to build something that has not been done before, but you can have some overlap, for example, a hot dog classifier, you might be able to download the weights of a certain neural network and add a few of your own layers so that the neural network can be trained with a small data set, so that you don't have to send like 10,000 images of a hot dog for it to train itself. You only need 100, because you add in the rest of the shapes, which is pretty neat. But now comes, of course, the interesting part for the neural network, or for the Mendix Meetup. How do I use it within a Mendix project? Well, for a client, we used option 1. Basically, what we had was a neural network which was fully trained with the data of that customer. We exported the weights of that, and we connected into Mendix with a Java machine learning package. And we created a vector within the application, set it through the neural network, and we got a result from that, which of course has a few advantages. But what we have for the demo in the moment, we also hosted it in a virtual machine, and we called it with a web service, which is also quite handy. And both have, of course, advantages and disadvantages. If you have it locally, of course, if you're handling, for example, banking details or a picture of someone, that's quite security is then quite an issue, because you want to be compliant. Speed, of course, if your server can handle it, otherwise the virtual machine would be better. And because you don't have to host it, cost could be a factor. However, if you are going to do image processing or very heavy calculations, then a virtual machine would be the best place, because it has a lot more speed processing power than your laptop probably. And you're also more flexible in the programming language for Python or something like that on the other side. So, in preparation of the demo that we did, we used one-shot learning. Basically what that means, it's a sort of trick in machine learning, that we did not train a model for a specific face, for facial recognition, but the model already knows what a face is, so it can determine that. And we have one image that we have as reference, and we add another image, and basically if they match according to what a face is through the neural network, it will tell us that there is a match and that person is the same. So, the moment we've all been waiting for, a demonstration. So let's see. So this is Counterdict, which is basically our neural network application. And we have 3 functions today that we're going to see. The first one is to recognize whether Elton John is among us. The other one is to detect Jan de Vries, who might be here. And how many persons are in this location at the moment. So to make it also nice, I want to ask.
It would save a lot of time taking attendance, by the way.
Yeah, it could be cool.
Everyone's here.
So let's see if I can open it on the mobile app. All right. Yeah. Got it. Okay. So Jan, would you be so friendly enough to show us? Select an image from Google from Elton John. I can already tell you a young Elton John will not work because it's too different.
Okay.
That one. Okay.
Let's do that one.
We can test both, luckily.
I'm using it as a background on my phone.
Okay. Okay, so the image is now saved, as you can see. I'll continue on this computer just for the presentation-wise. And we will check, is this Elton John? So what we already have an image of Elton John in the background against this neural network, and we now will add the picture that we have, and we'll see if there are correlations between the two. And if they're high enough, it will say, success, this person is Elton John. So that's fun, but of course, maybe it's, we just say it's a happy flow, like it doesn't really work, like this was a random image, so it should work. But we can also say, with another image that I have, is this Elton John? Very interesting.
I mean, Elton John has a lot of weird faces.
Yeah. Success. This person is not Elton John.
Oh.
Ah. Yeah, you would assume it is. But of course, we also have Jan de Vries who wanted to volunteer for our showcase. So thanks for that. But can I take a picture of you and we'll put a reference against it? So let's see. Oh. Okay. So let's see. Okay. So here we have the image once again. Holy moly. Is that Jan de Vries? It's now quite interesting to see if the background is also on it, if it makes sure that it's detected. Fingers crossed, everyone.
Close the door.
Yes. But you can have a lot of fun with this, but of course, making a neural network just to detect if Jan de Vries is here, while it is very important for our lives and makes it a lot easier, it might be a little bit arbitrary. So you might want to have a more general use case to have this. So, for example, but for the final part, I want to ask the audience also for their help. Am I allowed for people to go over there and I'll take an image of them, and then the neural network will count how many people are in the room. So the people who want to be part of this test, can you please go over there? Then I'll make an image of everyone. I think almost everyone. Okay, this is okay. Whew. Yeah, I think this is going to be hard. I think people shouldn't be that shy. Okay, let's see.
Wait, before you take a picture.
Well, I got a picture, so I'll play it now. No. Because I'll already tell you, probably that neural network will have a lot of difficulties with this. Okay. So what we now do is we do the object recognition that we saw before, and it will put a box around everyone, and it will count amount of people below. Yeah, true. Yeah, but the thing is that it's not perfect, and I'll also show you in a moment. But it is a quite nice use case, because you already see it gives a quite accurate indication of what the amount of people there should be. However, it's not flawless. For example, I have here a video. YOLO is called You Only Look Once, by the way. I did not come up with that name. I wish I did, but I didn't. But what you see here now is people at our office with a video running with the object recognition. And in a minute, I will walk by, and you'll see that the neural network has a lot of difficulty determining what I have in my hand. You can even see a skateboard, TV monitor. So it's not perfect, but it does give an accurate indication. So yeah, basically in short, that is my presentation. In the meantime, I'll keep this running. So are there any questions?
What is the number that you see?
The number are the amount of persons which are always in the screen at the moment.
But I mean, so for the boxes.
Oh, the boxes? Yeah, the probability. Oh.
How likely is that this is a person? 91. What's the other 9%? Is it cats?
Well, what you can even see with the image that I had before with the cat, it said the probability of the cat was 84%, which is bizarre because everyone can see that it actually is a cat. You know, it's common knowledge. But however, the computer has to learn it. Well, you have also learned it by watching cats on YouTube or in the streets or at other places, but the neural network is basically just like a human brain and has to keep learning what it exactly is, and maybe like a shape in the background, is that indeed what I think it is. For example, if you have an image in which the photo is very focused on the front and the people in the back are a little bit blurred, then we know that it's a person. However, if you go further, with the neural network, we'll probably not know it's a person. It will just be a shape which it cannot classify, and it will become a skateboard. Even everyone knows it's a laptop. So it's not perfect, but it's a step in the right direction.
Are you using a neural net for the object detection as well?
Yeah.
So you do first the object detection, and then for every object, an object recognition?
What exactly do you mean? Like,
I mean, there's a person on the right.
Yeah.
You first put a box around it, and then say this is a person. But who's doing the boxes? Is this all?
Oh no, that's also the neural network. So this video was sent and analyzed by the neural network, and it classified already in its neural network surrounding 80 objects, such as a skateboard, a cup, a desk, a chair, and it analyzes it frame for frame, and the neural network determines, okay, based on this frame, I think this is a chair.
That's not what I understand.
Yeah?
Who is making the frames?
I think the data which is sent back actually contains the coordinations within the picture where the object also is.
Yeah.
So I think in the Mendix application it's actually some custom code, I think. Did Gerwin do it? Or?
No, it's Govert.
Okay. But what they're basically doing is just drawing these boxes over
Yeah.
within Java.
That's not a neural network.
It's not
Yeah,
a neural
what
network.
you see
the,
here
the,
is,
neural,
right?
the neural network is identifying the places, and then we know the coordinations, and then we draw boxes over them. I think we do it in our own code.
Yeah. No, I think
It's not the
no.
neural network. The drawing is not the
Uh,
neural network.
Oh, all right. Yes.
I think
It's just doing the
well,
coordinations.
But ik zie.
I think
Mensen zitten.
no, because the image that we sent back, that was also determined by the neural network. These are people.
Exactly. So you send a normal video, and you get it back, including the estimate. As we saw in the picture that Peter took, with all the boxes surrounding the estimated people. but you have to train it with like, in this case, like 3 pictures of Jan de Vries and a few pictures of Elton John.
Yeah.
They don't have to be video, of course.
No, 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 no.
And then the neural network now is live guessing, are these people?
Yeah.
And per frame, it adjusts. So, was it the person, the last frame that
Yeah,
probably
yeah,
is
the movie part is clear, of
Yeah.
course, yeah.
So is there a threshold at which it decides, like, this is actually a person?
Yes.
For example, when you took a picture of me, what was like the percentage at which it said, we can reasonably assume that this is?
Yeah, it's a tough one because it does change quite a lot. But for example, with the customer at which we implemented this, we hang the weights and we get 4 results back. And the 4 results basically give a probability that it's 0, 1, 2, or 3. And the difference, which one is the highest, determines which one is the classification. But what we always see is that one is always 95 to 100 or 99%, and the rest is 0.001, something like that. So you can clearly see the difference between the two.
As we're analyzing pixels, right, does it also mean that you can improve the performance of the neural network by matching as well the pixel density of the pictures that you're training it on with the actual resolution of the camera that you're going to use in the end?
The more pixels you have, the more the better the neural network will be trained. However, it's always a compromise between what will you get? You know, will you get the standard iPhone camera, or will you get like from a real good photo camera? That will be a lot of difference in how you can determine what things are. But I haven't trained the network myself. Like I haven't done the person recognition myself, but I can imagine that it will help determine. But speed up the process, I'm not really sure. Because you still have to go against the whole network and put all the filters on top of every image to make sure that it is dense enough so that you can do it through the neural network.
How much effort it is to to capture the picture of the person and search for his LinkedIn profile picture? So you can,
Yeah.
is it possible?
What exactly do you mean? So that you can find the LinkedIn
I want
photo?
to have
Yeah.
the name of the person
Yeah.
on top of it with his link to his LinkedIn profile, based on his photo of LinkedIn. Is that possible?
It probably is, but it would march into very dangerous privacy territory, I think.
And also you'd have to have every picture on LinkedIn.
Yeah.
That's the problem.
Can you make a search for similar images, like?
Yeah, but you would have to have a
Yeah.
yeah.
Then if it showed up results that are such a perfect match that it should be that person, and that's a LinkedIn link, then you'd know who the person is. Or for Facebook, for instance.
Yeah.
Or your Mendix profile.
Yeah, or managed profile.
Yeah, but as you can see, it will probably take a long time. So as Wouter also indicated, probably what would happen is that you already have a neural network which is trained in faces, and you would go through images one by one. Is this person A? Is this person B? Is this person C? And eventually you'll get a match.
How many pictures did you use from Jan?
For Jan?
Training?
1.
Just 1.
Yeah, we got 3, but we used eventually 1.
To train it.
Yeah, yeah, because we already had the neural network trained to detect faces. However, to make sure that we can assume that this is Jan de Vries, we had 1 image of Jan de Vries, and we put the new one through the neural network, and they have similar output then regarding the face characteristics. So we assume that it's Jan de Vries.
I'm not sure if you already said it, but
Mhm.
you use trained weights. You
Yeah.
download the weights and put them in your own Java library, right?
Yeah, so we trained the application,
I wonder,
or train the network.
yeah, where did you train this?
In this case, we trained a Python application in which we built a neural network based on we know what the input is and what eventually the result was from said use case. And from that, a Python model was built in which, okay, if this happened, then we should classify the customer as 1, classify it as 2, and that should trigger certain types of logic, or say, accept the customer, reject the customer, or do something with it. And from that, we exported the weights as a file, which we then call within Mendix with a Java action.
And that all uses one particular library, I guess, for the neural network.
Mhm.
And which library is that?
That was the machine learning library. I think Gerbils, if I'm not sure. I can look it up for you. It's quite easy to find.
Mhm.
Are you able to say a bit about how we applied it in real world or not? Since we haven't checked, but I can give a bit of a context because it's not related to image classification. It's related to making sure that a certain company is a company you want to do business with. And of course, there's multiple service providers that do the screening for you, and they of course are looking into machine learning. So right now, we can tell you that there are companies in the Netherlands using machine learning and Mendix combined to help you make a better decision on whether you want to do business with a certain other company, which we think is a cool
very cool
application of machine learning and Mendix in real life. And of course, we know how many people are here. That's also good to know. But and one of them is Jan de Vries or Elton John.
Okay. No further questions, and thank you for coming.